Guys, hope you all doing well. So here we are going to analyze each and every question of CSIR net chemical sciences with best conceptual analysis along with the extra information which may useful for you for your further preparation. So watch the video completely and click on like and do subscribe our channel for further updates. And if you are interested further, you can visit our website chemmasters.online to join the best concept oriented online courses and to practice very high standard online test series along with mock test to boost your success rate. Okay, now just come to the point of question. The correct match for column A and column B is. So here we have given with lanthanide ions. And we know that, and if we look back at previous year papers of CSIR and chemical sciences, so we may conclude that at least one question comes from lanthanides in each and every paper of CSIR and chemical sciences. That's why it is very important topic. And here the valency electronic configuration is the most important for lanthanides and actinides. That's why one should have command on valency electronic configurations of lanthanides and actinides. Okay, so here we required the electronic configurations, that is valency electronic configurations of lanthanides. And here I'm going to give a kiddie method, that is a tricky method which may be useful for you, and I can say you may have better tricky method than this, but if you feel it is good and it is easy, you can try it. Okay, right, I can start from leftist party, that is a C, P and M. In the place of M, just substitute N. Okay, so just remember this triode, that is a CPM. Okay, so C indicating cermium and P indicating praseodymium and N indicating neodymium. Okay, right. And the next one, PSE, that is a primary school education. So just remember this triode. Okay, so here what we say, promethium and samaracium and europium. Okay, and the next the very popular sentence, a word here, what we say, G, yes and T. So just ignore yes. Okay, so just remember GST triode. For the G we can give gadolinium. So for T, terbium. Okay, after GST, now just another popular one, what we say, D, T and H. So just ignore T, but remember DTH. Okay, so DTH TV, in that case here dysprosium and holmium. And next very popular TV in India, that is E, T and V. In the place of V, just substitute Y. So now you can see erbium, thulium and ytterbium. And the final one is simply lutetium. So these are the triodes you should remember. The first one CPM, the second triode PSE, primary school education, the next triode GST, so just ignore yes. Okay, and next one DTH, and next triode ETV. Okay, next and lutetium. Okay, now we can start from the electronic configuration, valency electronic configuration of a cermium. For that, the electron enter into F orbital. So 4f1, 5d1, 6s2. So we can start from here. In the next praseodymium, the d electron move into f orbital and next electron enter into f orbital. That's why for the praseodymium we can write F3. For the neodymium, F4. So here promethium, F5, samaracium, F6, and europium F7 and gadolinium F7. But here from F3 to F7 of europium, so they do not have electron in d orbital. So simply 4f and then followed by 6s2. Okay, and now in gadolinium, the electron enter into d orbital, so 6s2. Why? Because to maintain this half-filled electronic configuration on f orbital, which is the stablest configuration for gadolinium, that's why the next electron just moves into d orbital, right? And after the gadolinium, the d electron moves into f orbital. Okay, so in this case here, and next electron move into f orbital. So here we can write f9, then f10. For the holmium, f11, next f12, then f13. For that ytterbium, f14. So till to this, no electron in d orbital. Then the next one is s, so 6s2. Now in the lutetium, once again the next electron move into d. Okay, so d1 and 6s2. So this is the way you can simply remember the lanthanide valency electronic configuration, right? And from this you have to pick up for the terbium plus 3. So for the terbium, so here f9 6s2. Now 3 electrons are lost from it. For the terbium plus 3, now we have 8 electrons in its f orbital. Okay, right. And next lutetium. So for the lutetium plus 3, what happens? These 3 electrons are moves out from the valency orbitals. In that case, sorry, just wait, lutetium, right? And in this lutetium plus 3, we have 14 electrons in f orbital. Then the next case is samarium plus 3. Just come here, F6 and 6s2. So 3 electrons are moved out. In that case, samarium plus 3 have 5 electrons in its f orbital. Then next case, europium plus 3. Come here, where F7 6s2. So 3 electrons are moved out. Then here we have F6. Okay, so these are the electronic configurations we should have to check out the matchings in column A and column B. Okay, right now, so just try to look at the lutetium plus 3 where the f orbital is completely filled. The valency orbital is completely filled. That's why there is no possibility for FF transition, right? So simply the A matches with lutetium plus 3. Now just try to check the terbium plus 3. So here terbium plus 3, which is having 8 electrons in its f orbital, we need to find the term symbol for it. Okay, yes, so just try to fill up 1 2 3 4 5 6 7 8. Okay, now here 0 minus 1 minus 2 minus 3, just give ml value magnetic values. Okay, so plus 1 plus 2 and plus 3, right? Now so this is the general electron filling according to the electron filling rules. So we can find the ground state term symbol for it. Yeah, so here just cancel the electrons, and here we have one electron in so which is having plus 3. So here we know that L values start from 0 1 2 3 4 and they goes on. Yeah, for L is equal 0 we can say yes, and if it is 1 we can say P. For 2 D, and 3 F. Okay, like that. So just moves on, and here we have 3. That's why L value equals to 3, and which is showing the term F. Okay, now we need to find what the spin multiplicity. So to do that, we need to find the spin of unpaired electrons. Here we have how many unpaired electrons are there? So simply 6 electrons are there. So n by 2 here, n indicating number of unpaired electrons. So just take it, 6 by 2 is equals 3. Now the spin multiplicity 2s plus 1. Just substitute s value here. So 2 into 3 plus 1, we can get 7. So here F7. Now we need to find J value, right? So J value depends on L and S. So here L plus S2 and L minus S. So we can, L value is 3 and S value is 3. So 3 plus 3 is 6. So 5, 4, 2, 1, 0. That's why here J value is represented with N here. Okay. So J value is represented with N in the question. Right. So this is the term symbol we can observe, right, for this terbium plus 3. Now just try to check. So here the general term symbol for terbium. So just try it. Write down 7En. Now I'm going to check for the europium plus 3. Europium plus 3. So for which, how many electrons are there? 6 electrons are there. Now just try to fill up. Yes, so 1 2 3 4 5 6. Okay, so here is the okay, 6. Now 0 minus 1 minus 2 minus 3, and just do the same thing here. Okay, Now these are cancelled each other. Okay. Oh, sorry, just fill properly. Just wait. So don't get the clumsiest drawing here. So now 1, 2, 3, 4, 5, and 6. Okay, 0, -1, -2, and +1, +2, and +3. Here is the -3. Okay, now just cancel. So 1 and 1, 2 and 2, and here we have one electron in 3. So L equals to 3, which indicating F orbital. Sorry, F term. Okay, right. And after finding this, we need to find S. So spin is equal to n by 2. And how many unpaired electrons are there? 6. So 6 by 2 equals to 3. Now 2s plus 1 equals to 2 into 3 plus 1, which equals to 7. That's why here it is also showing F7 and the J value, which can also from 6 to 0. That's why we can take it as N here. So F7. Here what you are just finding for terbium plus 3, it is Fn7, and also for europium plus 3, if it is Fn7. So okay, these are the ground states. Yes, and the next term symbol D5. So it is the simplest one, no need to calculate, but no need to find the term symbol. So we need to look at the J values. Here we have two of them, D05 and another one D4, 5. So here J value is minimum for this. Okay, and here we have maximum J value. We know that for less than half-filled electronic configuration, we can take the lowest to J value as the ground state. Okay, now try to check in terbium plus 3 and europium plus 3, which is having less than half-filled electronic configuration. Here, europium plus 3, which is having 6 electrons only in its valency f orbital, whereas terbium is having more than 7, more than half-filled, 8 electrons are there. That's why here europium plus 3 is having less than half-filled electronic configuration. So for this, so the transition is must to the term that is D05. So europium plus 3 combined with D05. Okay, so for terbium plus 3, whenever the electronic configuration is more than half filled, for that the maximum J value is considered as ground state. So here the we can in the given possibilities, so the maximum J value is 4 on the given transition. So here terbium is combined with this emission. Now simply for the summation, the overlapping of J values. Okay, so now just check the correct combinations in the options, and from that you can pick you can find the correct answer. Okay, right, thank you very much.